Welcome guys, today I am going to demonstrate the technical review of a graphic equalizer EQ700 by Behringer. As there are few numbers of unboxing videos available in the YouTube, so I decided to present this technical review. The equalizer is fed with the input signal from a function generator, and the output signal from the equalizer is observed in a DSO digital signal oscilloscope. Here the yellow line is the input signal at 100 mV per division and blue line is the output signal at 200 mV per division. I am running it with a 9-volt battery, though there is a provision of connecting a 9-volt DC power supply. It is a 7-band equalizer. Everything is described clearly in the product manual. Here each band represents its corresponding frequency power, and here is also a final level controller. In a real-time scenario, this output will be transferred to your power amp and the input signal from your pickup of your instrument like guitar or violin will be inserted here. Now the equalizer is set to the bypass mode. So you can see, though the input square wave, the yellow line has full of high frequency glitches, but the output signal, the blue line, has very less glitches, and it is also a kind of square wave of that same frequency. You can check the menu output of the DSO. Before going further, I must explain that why I have chose square wave to test this equalizer. A square wave is a collection of many sine waves. For a specific frequency of square wave, it is constructed with a sine wave of that exact frequency known as baseband frequency and the harmonics of that sine wave. When we play guitar, the pickup of the guitar catches a collection of sine waves of different frequencies. Here you can see that the frequency of the square wave is 131.7 Hz. That means it has a baseband sine wave of frequency 131.7 Hz and the high frequency harmonics of that sine wave. Now if I increase the frequency of the input signal, the frequency of the output signal will also increase accordingly, but the output is still noise free for high frequency operations. Look, there is no glitches in the output, and still the output signal is look like kind of square wave. Now I am going to activate the equalizer. You can see the output voltage will increase, and when the equalizer will activate, the red LED of the pedal will also start to glow. The level is set at 0 dB, so the output is set at 139 mV RMS for the specific input. Now if I increase the level, the output voltage will also increase up to 462 mV RMS, and if I decrease the level accordingly, it is decreasing. So the level now is working properly. Now I set it to 0 dB. As I have already mentioned previously that a square wave have full of collection of sine waves, means the baseband sines and its harmonic. So here for 131.9 Hz square wave, now if I increase the 100 band knob and decrease the higher frequency knob in the pedal, then the baseband sine wave of 131.9 Hz square will come to the front. Look, it's a sine wave. Now I am increasing the input signal frequency for the next band, which is near 200. Here in the pedal I am decreasing the level of 100 and increasing the level of 200. Look, the baseband sine is coming out. I increase the voltage per division of the output to 500 for better visualization. In the same way, I am increasing the input frequency for the third band of the pedal, which is near 400. Now I am decreasing the level of 200 and increasing the level of 400 to visualize the baseband sine of 419.4 Hz. Now again I am increasing the input signal frequency for the fourth band, which is near 800. Here in the pedal I am decreasing the level of 400 and increasing the level of 800. Look, instead of the square wave, the 790 Hz sine wave is coming out. In the same way, I am increasing the input frequency for the next band of the pedal, which is near 1.6K. Now I am decreasing the level of 800 and increasing the level of 1.6 to visualize the baseband sign. Now the next band is for 3.2K. I am increasing the input frequency and adjust the band knobs, likewise the previous bands. Look, the sine wave of 3.23 kHz is coming out. But the last band of 6.4K is little bit different from the previous bands. I am increasing the input frequency to near 6.4K. And now I am decreasing the levels of all other bands except the 6.4K and increasing it. But look, the output signal is not at all sine wave of 6.4K, kind of mixture with some higher frequencies. So this will be the nature of the output wave after applying the equalization. Now finally I am going to show the FFT or spectrum response of the output signal from the equalizer, where I have chosen the input square wave of a 440 Hz from the function generator, which corresponds the middle A4 key of a grand piano. Here the EQ is set to 400 band, so a sine wave of 440 Hz is coming out from the EQ. Now I will show the FFT response. Look, there are some peaks. Yeah, yes, there is a peak of 440 Hz. Now if I increase the levels of the higher bands of 400 in the pedal, look, the harmonics of the 440 Hz are coming out. I am increasing the higher bands. And if I decrease those levels, then harmonics of the 440 Hz are going away. But still there is a harmonic which is 880 Hz, double of the 440 Hz, means pitch A5 in the piano. This EQ can be used as low pass filter, band pass filter, band reject filter, and also high pass filter. So I can conclude in this way that this graphic equalizer could be a very good choice for the entry level musicians for the string instruments, though it has a plastic body, but it works like a magic. If you like this video, please like, comment and share. Thank you.